to the next point. We should ensure whatever we see is clear.
That means work is being done. We can see that it is in opposite direction.
Hello, dear listeners and viewers at home. You are welcome to another e-learning lesson on computer studies for senior secondary school education. I remain your computer teacher, Ganiat Olarinoye. In our previous lesson, we discussed on the topic computer data file. Today, we continue with the computer data conversion. My dear listeners at home, before I start with the introduction of the topic, I believe you all familiar with the word data because the data is the smallest unit of the information or the raw fact, symbols, or figure that is being processed to produce information. That's the literal meaning of data. Computer data conversion. We have some outline on this topic. We have the register, we have an address, and we have a bus. We have types of registers and their functions. The differences between a register and the main memory. We have the operating procedure of computer data processing. And finally, we have factors affecting the speed of data transfer. Starting with the definition of computer data conversion. Data conversion is the conversion of computer data from one format to another. Remember, I told you that the data is the smallest unit of information, and the data conversion may be as simple as the conversion of text file from one character encoding system to another, or more complex, such as the cover of office file formats, or conversion of image and studio file formats. File is the collection of record of students. I gave an example. If you follow the previous lesson, we discussed the files. Now, when we have the collection of records, that's what gives us a file. Using the school academic database, we have record of data of students. When you have the collection of the students, starting with the student's name, student admission number, student sex, student's age, all this, each of the item is a field, or we call it a data item. When we have the collection of these data items, that makes a record of a particular student. And when we have the collection of the record of students, we have what we call a file. We have the register. A register is a special high-speed storage area within the CPU. A register is a storage, it can serve as a memory storage. That is the register. It's not your normal register or your attendance register that you use in a class. This register is a memory and is mounted on the CPU. My dear students, don't get confused between the CPU and the system units, because some students interpret the system unit with the CPU. The CPU is the central processing unit and is being mounted inside the system unit. All data must be presented in a register before it can be processed. That is the register. The next is that we have an address. Address does not mean your home address. I'm referring to the address on the CPU in your central processing unit that is being embedded in your system unit. An address is used to reference a storage location in the main memory, or is a number used to locate a position in a memory or some other devices. This address is usually mounted on the main memory. Remember, we have different memory. We have the main memory and we have the auxiliary memory. The main memory is also called the primary memory, while the auxiliary memory is also called the secondary memory. These are the two types of memory that we have. The next is the bus. A bus is a collection of wires through which data is transmitted from one part of computer to another. Take for example, using your system unit's case, there is a motherboard inside the system unit. There is a traces of bus. You will see it's just like a metal drawing on the board. This drawing is not just an ordinary drawing. That is what we call a bus because it transmits signals in the CPU. There. That is a bus. A bus connects all internal computer components to the CPU and the main memory. That is the central processing unit. And I told you that the main memory is the primary memory. The next is that we have types of registers. There are different types of registers. The types of registers are memory data register, that's the MDR. We have the current instruction registers. These are the main types of registers that we have. But there are others. But in terms of examination question, if you are asked to list types of register, you first list these two. That's the memory address register and the current instruction registers, but there are other registers as listed above. Others include memory address registers, that's the MAR. We have the program counter, which is the PC. We have the accumulator, the AC. We have the instruction registers, that's the IR. And the memory buffer registers, that's the MBR, among others. My dear students, from there, we lead to functions of registers. What are the functions of these registers? One, taking the memory data registers, that's the MDR. The memory data register is used to hold data or the memory address that contains either the next piece of data or an instruction that is to be executed. Now, take for example, how does the system work? The system, that's your computer system or your mobile phone, it all serves the same purpose. And it has a specific way it's functions. We have what we call the IPO. That's the IPO cycle. That's input, process, output. My dear students, you are all familiar with this alphabets. The input means you are imputing, that you are typing your words, your data or your document into your system. So you are imputing your data into the system. After imputing, using your keyboard, that's your input device. Then it's being processed, that's the P. It processes your data that is being imputed into the system using the central processing unit. After the processing product, you have to get your output. And this output is what we refer to as the results or the answers that we derive from the processed work. That's the abbreviation of IPO, that's input, process, output. The next function is that we have the memory register. The memory register that acts like a buffer and holds data that is transferred from the memory to the processor. That's another function of the memory address register. The third one, the memory data register is used wherever data is being transferred between central processing units and the main memory. The main memory is being attached to the central processing unit. That is why you say the memory that transfer is the memory that always transfer data to the CPU directly. unlike the secondary memory, which is our external storage, before it's being what? Transfer of data from the external storage, because it's an external device, it's not attached to the system. That's one of the major difference between the main memory and the auxiliary memory. The next is the current instruction register, which is the second type of register that we have. One, we have current instruction register is the register, usually in control units, that contain the instruction that is being executed by the CPU, that's the central processing unit. That's the function of the current instruction register. The next is that we have the current instruction register stores the instruction currently being executed in simple processor. Each instruction to be executed is loaded into the instruction register, which holds it while it is decoded, prepared, and ultimately executed. What do you mean by when we code? We have code. That when this code is being decoded, that's by changing the format. In our previous lesson, I told you, we code and we decode using the simple instruction. So that's the essence. Maybe sometimes for security process, if you can recall, my dear listeners, we talked about encoding and encryption and decryption under the security ethics. That when you want to secure your what? Your information or your data, we encode. That's the essence of encoding is for security purpose. All this just to avoid what? Hacking into your private documents or your file. The next is that we have differences between register and main memory. This question is a question that usually appears or is a wire question and NECO. So please take notes of this. That's the differences between the register and the main memory. Some students will say that register is the same thing as the main memory. No, there's difference between it. So we have some of these differences. One, register has temporary storage in the CPU that holds the data the processor is currently working on. That's the register. That is when we have a data. When we are working on this data currently, that means it only stores the data temporarily. It doesn't store the data permanently. That is the reason why we have what we call a RAM and a ROM. The RAM is the random access memory, and the ROM is the read-only memory. So the RAM stores data temporarily, while the ROM stores data permanently. That's the difference between the two. The main memory, also known as the RAM, it holds the program instruction and the data the program requires. That's the main memory. The next difference is that the registers are located in the processor instead of in RAM, so data can be accessed and stored faster. That's under the register. And when we come to the main memory is fast storage that is directly accessible by the CPU, that's the central processing unit, and has the capacity to allow data to read and to be written. That's another difference between the register and the main memory. The next is that we have the data fetch execute cycle. These data fetch execute cycles also refer to the cycle in which our system works. As earlier discussed in the lesson, I told you that we have the IPO cycle. It also functions the same with the data fetch execute cycle. Thus, the fetch data cycle is the very basic way a computer works. All commands are executed through the running of this cycle. As soon as the computer is powered on, that is when you switch on your computer system, it begins the processor of the fetch execute cycle. That is the moment when you switch on your computer system. Remember, it depends on which of the computer system you are using, because we are different types of computer system. We have the laptop, we have the desktop, we have the mini computers. All functions the same time and the same way. But the way of switching off the system differs. Take, for example, when you are using your desktop, you have the components of the desktop that you are using. We have the monitor, we have the system units, we have the keyboard, we have the mouse. All these components have to merge together for effective use. We have the system unit is being connected with the monitor, the mouse, together with the speaker. Unlike when you are using your laptop, you just have to press the press button on your system or your mini computer or your notebook computer. But the desktop, you have to follow from one procedure to the other, starting from the source of supply, that's your socket. You on your socket, followed by either your UPS. And the essence why you use your UPS to connect with your system unit is because of the fluctuation or power, so that it will regulate or it will retain some charges for you in case there is power failure. And we also connect it with the stabilizer just to attend the fluctuation of the electricity in order to avoid damage or failure to your system. When you connect this power source to your system unit, it's now being connected to your monitor, to your keyboard, and to your mouse. You now press the keyboard or the button on your system unit before it started booting. That's the process of switching on your computer system. So it differs from using your laptop and your mini computer. That's the fetch execute cycle. It contains three main parts. The first is that we fetch the instruction. How do our data that we have to fetch it into the system. The next instruction is fetch from the memory address that is currently stored in the program counter, that's the PC, and stored in the instruction register, that is the fetch instruction. After fetching the instruction, we decode. The decoded interprets the instruction. During this cycle, the instruction inside the IR, that the instruction register gets decoded. Now, the moment when you fetch, you decode. That's the next step. The next is that we have to execute the instruction. After fetching, we decode, then we execute. The control unit of the CPU passes the decoded information as a sequence of control signal to the relevant function unit of the CPU in order to perform the action required by the instruction, such as reading values from register, passing them to the ALU. ALU, that's your arithmetic and logic unit. And this is one of the components of the CPU, that's the ALU, to perform mathematical or logic functions on them, and writing the result back to the register. The next is that the operating procedure. The operating procedure of computer data processing. What are these procedures? The data processing consists of all the activities which are necessary to transform data to information. In our lesson, I discussed this as the data to information. Before you can have the information, you have to process the data, because it's the data that gives us the information in a meaningful form. When you have a phrase or incomplete sentence, we cannot call it an information because it does not give us complete sentence. That is, when we have Amina, we have Go, all these are data. When we have the collection of all these data together and it gives us meaningful information, that is when we have an information. The various functions and activities which need to be performed for operating procedures of computer data processing can be grouped under 5 basic categories as shown below. 1, we have the collection, conversion, manipulation, storage, communication. These are the 5 basic ways in which we collect the fetch, data, decode. The next, under the collection, data originates in the form of event transaction or some observation. This data is then recorded in some usable form. Data may be initiation, recorded on paper, source documents, and converted into machine usable form for processing. Remember, we know that our computer has a language, which consists of the binary, which is the zeros and 1, as earlier discussed in our previous lesson. The next is the conversion. Once the data is collected, it is converted from its source document to a form that is more suitable for processing. The data is first codified by assigning identification codes. A code comprises of numbers, letters, special characters, or combination. We can have letters, characters, and the combination of both. The next is the manipulation. Once data is collected and converted, it is ready for the manipulation function, which converts data into information. Thus, the manipulation consists of the following activities. We have sorting, we have calculating, summarizing, and comparing. This is under manipulation. The next is that we have sorting. That the sorting involves the arrangement of data in in a desired sequence. The calculating, that arithmetic manipulation of data, is called calculating. We have summarizing. To summarize is to condense or reduce masses of data to a more usable, concise form. Comparing, to compare data is to perform evaluation in relation to some known measures. The next is managing the output results. Once data have been captured and processed, the following activities may be carried out. We have storing and retrieving. To store is to hold data for continued or later use. And to retrieve, it means to recover or find again the stored data or information. Communication is the process of sharing information. Reproduction, to produce, is to copy or to duplicate data or information. Documents and reports can be reproduced. Factors affecting speed of data. We have factors that affect speed of data. The time data transfer refers to the amount of digital information that moves from one computer device or to another computer within a given period of time. The factors that affect the speed of data are, we have the bus speed, bus weight, medium of storage, and data transfer medium. These are the 4 basic factors that affect the speed of data. The bigger the data bus, the more data can be fetched at once and processed, making computer faster. When we talk about the bus weight, refers to how many bits of information the RAM can send to the CPU at the same time. Medium of storage, we are referring to the storage device. That's the different storage medium have different data transfer speed. The last is that we have the data transfer medium. Different data transfer medium have different transfer rates. So these are the major factors that affect the speed of transfer. My dear students, I hope learning has taken place. Before I leave you, I have a little assignment for you to make or use the ability of the lesson being had. 1, we have an assignment 1. I want you to define a register and a bus. Assignment 1, define a register and a bus. 2, list type of register. List types of register. Question 3, state one function of 1, that's the MDR, the memory data register, and CIR, which is the current instruction register. Question 3, state one function of memory data register, that's the MDR, and current instruction register, which is the CIR. Question 4, list any 3 factors affecting the speed of data rate. I gave you the speed, the factors that affect the speed of data, but I want you to list just only 3. That's list any 3 factors affecting speed of data transfer. Now, for further research, comments, or more explanation, you can contact me. I still remain your computer science teacher from Senior Secondary School, Ganiat Olarinoye. My number is 080-3737-7900. Let me take it again, 080-3737-7900. Stay safe, stay home, keep learning. Have a nice day.